In this episode, we take on a topic that can sound intimidating at first, but becomes very manageable when you frame it correctly. Designing audit sampling for AI decisions so you can reveal bias and failure modes. New learners often hear the word sampling and imagine statistics formulas and complicated math. In an audit context, sampling is mainly a practical strategy for choosing which evidence to examine when there is too much evidence to examine everything. AI systems generate huge numbers of decisions, outputs, and interactions, so sampling is unavoidable. The important question is whether your sampling method is likely to uncover the kinds of problems that matter most, such as unfair patterns, consistent mistakes in certain groups, or failures that occur only under specific conditions. Bias and failure modes can hide because overall performance can look fine while certain populations or scenarios are harmed. Your goal is to learn to design samples that are intentionally shaped to surface those hidden issues, and to do it in a way that is defensible, clear, and connected to audit criteria and business risk. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Start by clarifying what you are sampling, because AI audits can involve sampling many different things, not just model outputs. You might sample decisions, such as accept or reject outcomes, risk scores, or triage classifications that influence a workflow. You might sample interactions, such as chat responses that guide customers or employees. You might sample evidence artifacts like change records, prompt versions, or monitoring alerts. In this lesson, we focus on sampling decisions, which means the points where the model's output changes what happens next. Decisions are important because they carry impact, and impact is where bias becomes meaningful, such as who gets approved, who gets escalated, who is flagged, or who receives a certain service level. When you design a sample, you are defining a window into the system, and you want that window to show both normal operation and the edges where failures appear. A sample that only includes easy, typical cases will make the system look better than it is. A sample that only includes extreme cases may exaggerate problems and fail to represent typical impact. Good sampling balances representativeness with deliberate stress, because you want to both understand the baseline and uncover hidden risks. Bias in an audit context is not only about whether the model is mean or unfair in an obvious way. Bias can show up as unequal error rates, unequal quality of service, or unequal likelihood of negative outcomes across groups, even when no one intended it. A model might produce more false positives for one population, meaning it wrongly flags them more often, or more false negatives for another, meaning it fails to protect them or fails to detect their needs. Bias can also be built into the data, where historical patterns reflect unfair treatment that the model learns and then repeats. Failure modes are the predictable ways a system breaks, such as misunderstanding certain language, failing on certain edge cases, overconfident outputs, or unstable behavior after updates. The reason sampling matters is that these problems do not always show up in random slices of data. They often cluster in specific contexts, such as certain user groups, certain types of requests, certain times, or certain channels. A strong sampling design aims to reveal those clusters rather than hoping they appear by chance. A practical way to design a sample is to begin with the audit objective and the business risk, because those define what you are trying to learn. If the risk is unfair denial of service, then the sample should emphasize denial decisions and compare patterns across relevant groups. If the risk is inaccurate triage that delays response, then the sample should focus on high-severity classifications and the cases near decision boundaries where mistakes are likely. If the risk is harmful advice or unsafe outputs, then the sample should include interactions and sensitive topics and outcomes that triggered complaints or escalations. Beginners sometimes start sampling by grabbing the first set of records they can access, but that produces weak results because the sample was shaped by convenience rather than risk. Instead, think of sampling as a test design. You are designing an investigation that tries to answer a specific question, and the sample is the evidence set that makes the answer credible. Now consider the difference between random sampling and risk-based sampling. because both can be useful, but they serve different purposes. Random sampling is good for estimating baseline behavior because it reduces selection bias and helps you understand typical performance. Risk-based sampling is good for finding problems because it deliberately focuses on areas where failures and bias are more likely or more harmful. In AI audits, you often combine them. You might use a random sample to understand the general pattern of decisions, then add targeted samples that focus on high-impact outcomes, rare but severe events, or populations where risk is higher. This combination is important because if you only use targeted samples, stakeholders may argue you cherry-picked bad cases. If you only use random samples, you may miss the most important harms because they are not common enough to show up. A defensible sampling plan often includes both, and it documents why each portion of the sample exists. The documentation is part of the audit evidence because it shows your approach was deliberate, not arbitrary. A key technique for revealing bias is stratified sampling, which is a simple idea even if the word sounds technical. Stratified sampling means you divide the population of decisions into meaningful groups and then sample within each group. The groups might be user demographics when legally and ethically appropriate, geographic regions, language categories, product lines, customer tiers, or any other segment relevant to fairness and risk. The point is that if you sample only from the largest group, you may miss failure patterns in smaller groups. Stratifying ensures that the sample includes enough cases from each group to make patterns visible. This is particularly important in AI because the model may be trained mostly on data from dominant groups, leading to weaker performance on less represented groups. Stratified sampling is not about assuming discrimination. It is about ensuring you can detect unequal outcomes if they exist. In audit practice, you also need to handle sensitive attributes carefully, ensuring you use them only when justified by objectives and permitted by policy and law. Another technique for revealing failure modes is boundary sampling, which focuses on cases where the model is uncertain or where small differences in input could change the outcome. Many AI systems produce scores or confidence levels behind the scenes, and even when they do not, you can often identify borderline cases by looking at outcomes that were close to thresholds or required manual review. Boundary cases are important because they are where models are most likely to make mistakes and where bias can show up as small threshold differences that disproportionately affect certain groups. For example, if a score threshold determines who is flagged for extra scrutiny, small systematic differences can create unfair patterns. Sampling near these boundaries helps you see whether the model behaves consistently and whether the organization has controls like human review or appeal processes that reduce harm. Beginners sometimes focus only on obvious wrong outputs, but boundary sampling finds the subtle issues that create persistent unfairness. It also tends to reveal where decision logic is fragile and where controls need strengthening. You also want to include negative outcome oversampling, which is a deliberate focus on the decisions that cause harm if wrong. Negative outcomes might include denials, escalations, blocks, fraud flags, or any decision that restricts access or triggers investigation. The reason is that even a small error rate can be unacceptable when the cost of a false positive is high, such as wrongly blocking a legitimate customer or wrongly accusing someone of misconduct. Oversampling negative outcomes helps reveal whether errors cluster in certain contexts or groups and whether the system has safeguards that catch mistakes. It also helps you evaluate the organization's process for handling disputes, corrections, and appeals, which is part of fairness in practice. In AI audits, fairness is not only about the model. It is also about the surrounding process that allows humans to correct errors. A sample that includes negative outcomes gives you evidence about both the model decision pattern and the operational response to those decisions. Time-based sampling is another technique that matters for AI because model behavior can drift or change after updates. If you sample only from one time period, you might miss a bias pattern introduced by a model update or a data change. Time-based sampling means you select cases from different periods, such as before and after a major model change, or across different seasons when input patterns differ. This helps reveal whether performance and fairness are stable over time, which is important because business risk is ongoing, not a one-time event. Time-based sampling also helps identify whether change management processes are effective. If a model update caused a spike in complaints or a shift in outcomes for certain groups, a time-based sample can surface that pattern and connect it to a specific change record. Beginners sometimes think sampling is static, but AI systems live in time, and the audit needs to account for that. Including time as a sampling dimension strengthens your ability to detect drift and to tie findings to actionable causes. Context-based sampling is also valuable, especially for systems that interact with humans through language. A model may perform well on standard, polite requests but fail on slang, misspellings, mixed languages, or emotionally charged content. Those contexts can correlate with certain populations, which means a context failure can become a fairness issue even if the model is not directly using demographic attributes. Context-based sampling might include different communication channels, different device types, different locales, and different phrasing styles. It might also include different content categories, such as questions that involve financial hardship, health, legal topics, or other sensitive areas where harm is higher. The aim is to see whether the model behaves consistently and safely across the contexts it will actually face. If you only sample clean, ideal inputs, you audit a fantasy system, not the real one. This is especially important in AI audits because the system's risk often emerges at the messy edges of human communication. Once you have a sampling design, you need a method for evaluating what you find, because sampling alone does not reveal bias unless you look for patterns thoughtfully. In an audit, you might compare outcome rates across groups, compare error rates across contexts, and compare the consistency of explanations or rationales where applicable. You also look for failure modes such as overconfidence, refusal to handle certain groups fairly, or inconsistent application of rules. The evaluation should be tied to criteria, so you can say what standard is being applied and why a pattern matters. For example, if the criterion is that decisions must be consistent and explainable for accountability, you examine whether similar cases receive similar outcomes and whether the system's decision trace supports that consistency. If the criterion is that high-impact decisions require human oversight, you examine whether oversight occurred in borderline or negative cases. Beginners should remember that auditing is about evidence and reasoning, not about proving a system is perfect. You are trying to see whether risk controls are adequate and whether patterns of harm are present. Documentation of sampling is essential because it protects the audit's credibility. You want to be able to explain how the sample was chosen, what populations were included, why certain cases were oversampled, and how the sample relates to the audit objectives. This documentation helps stakeholders trust the findings, even if the findings are uncomfortable. It also helps future audits improve, because you can compare samples over time and see whether corrective actions reduced bias or failure patterns. In AI contexts, documentation is especially important because the system may change, and a future team may ask why the audit looked at certain time windows or certain decision types. If your sampling method is clear, the audit becomes repeatable and the organization can track progress. Beginners sometimes underestimate documentation because it feels like administrative work, but it is a core part of audit quality. Without it, even accurate findings can be dismissed as cherry-picked. As we wrap up, remember that designing sampling for AI decisions is about making hidden patterns visible in a defensible way. You start from business risk and audit objectives, then combine random sampling for baseline understanding with risk-based sampling for problem discovery. Stratified sampling ensures you can see patterns across groups. Boundary sampling reveals fragility and unequal threshold effects, and oversampling negative outcomes focuses attention on the decisions that cause the most harm if wrong. Time-based and context-based sampling account for drift and real-world variability, which are common sources of AI failure. Finally, you evaluate findings against clear criteria and document your method so conclusions are trustworthy and actionable. When you can design sampling this way, you are doing more than checking whether controls exist. You are testing whether the AI system behaves fairly and reliably where it matters most, which is the real point of auditing decisions in Domain 3B.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.